Dear SAF and MBSE fans, today I would like to show you how elegantly physical interfaces can be modeled using the Systems Architecture Framework. When modeling physical interfaces, a common challenge is identifying and defining the different aspects of an interface, as well as the connections between them. The relevance of these aspects can vary significantly depending on the type of interface. For example, a discrete physical interface may involve mechanical, electrical, and logical aspects, whereas a software interface focuses more on protocol layers and data content. In this video, I walk through an example of modeling a hardware-oriented, more physical interface. A follow-up video will demonstrate a more software-centric approach. Let's dive in. As we can see here, we have a very simple example context showing a system of interest and external systems A and B. Looking into the connection details, we'll see that system A and system B each have a connection to the system of interest. Both show a separate type of interface, and we now need to create the details of each of these interfaces using SAF. I have already created a physical interface definition viewpoint, and we will now go ahead and fill this viewpoint. First, we're dragging the specific interface to system A onto the diagram. Now we're adding additional ports, one for each of the aspects we want to specify. Basically, this will be, in this example, the connector, the cable, and the electrical and logical signals. Each of the ports will be of type physical interface definition, provided by the SAF framework. Once we have created the physical interface definition types for each of the aspects to specify, we create specific interface layer mappings between two of the aspects. In this particular example, I have decided to link the connector to the cable and the cable to the signals. Now we can use the SAF toolbox to create interface layer relationship connections between the different ports according to the interface layer mapping we have created. As we have defined the connector to cable mapping between the specific connector type and the specific cable type, we are only able to choose this to type the interface layer relationship. We're doing the same for the interface layer relationship between the cable and electrical signals. We now define proper value types for each of the interface aspects, as we have the pin, the wire, and the signal. We are creating associations between those value types in the same way we did for the aspects of the interface. And again, we are creating interface layer mappings, e.g. from pin to wire, and we are assigning these association classes to the associations. Now we've got a full set of physical interface definitions, value types, and the corresponding relationships between them. We can now add pins to the connector, wires to the cable, and signals to the electrical signal set, and continue mapping these to each other. We can now add an internal block diagram to the interface layer mapping, for example, for the connector to cable mapping. We synchronize the structural elements and display the parts. We're doing so for both the cable and the connector. Once we've got that, we can create connectors between the pins and the wires. And we can type this connection with the mapping we have created between pins and wires. Once defined, we can simply, from the top-level diagram, see the concrete connection between pins and wires. We now continue doing the same for the assignment between wires and signals. Now we want to repeat the same for the second interface between the system of interest and system B. As we can see, we can easily reuse the connector and cable specification we have created for the connection between the system of interest and system A. But now we want to add another signal set specifically for the system B system of interest connection. So we move on, creating a new physical interface definition and creating an interface layer mapping to the specific cable type. Using this approach, it is very easy to create a library of standard connector and cable assignments. For each interface, you can then add specific signal sets, or even if you have standard signal sets, you can reuse them as well. I hope this video helped you to understand the approach in SAF to model physical interfaces. If you have any questions, don't hesitate to contact us.